Alright, so this one we're going to show you about the Arduino board, the breadboard, the different pins, and how to power your Arduino. Let's see. So our Arduino, there's several different ways of powering your Arduino. Anytime that you're powering or using the code or programming your thing, you can do it through the USB cable. You can power through here. After you're done and upload and saved, you then have the option to power through the battery cable. And that would be done through this little cable here. That will be plugged in to this side right here. So a 9-volt battery, you can plug this after it's done and programmed. You can carry it around and go around with that. Okay, our Arduino board, we refer to different pins. These pins will be these little different holes or ports that we can plug things into. We can plug in wires, we can plug in other things. These are placed straight down in here. Just like the breadboard, we don't need a connection. We don't need to solder it. It's just a temporary connection. Now our different pins were set up on different things. This section right here refers to our power pins. This section here is our analog in pins. This whole side refers to our digital pins. Our power pins, there's several different things like 5 volts. There's 2 5 volts. These would be like outputting 5 volts if we wanted to work with something with 5 volts. There's also a 3.3 volts. Depending on the sensor or whatever you're doing, it may change. You may want to use 3.3 or sometimes you may need to use 5. These next two are called grounds, GND, and that is to complete the loop. So if we have power going out, we do something, we also need power coming back in. If we didn't make it one complete loop and come back in to the ground anywhere, things would not work. This last one is VIN or volts in. That will allow us to power the board separately. So if we had like a battery, a 9-volt battery over here, we may not need to connect to over that one over there if we were to power from the breadboard into here. So this will power the Arduino as well. The analog pins, they're labeled as A0, A1, A2, A3, A4, A5. These are analog in. Analog means like voltage. So if I wanted to check like the voltage coming off a knob or a photo sensor or a moisture sensor or anything, a lot of sensors are analog sensors, and that basically depending on whatever it's sensing, it'll change the voltage coming in or out, or coming out of the loop. And these are read by right here, and they usually try to have the volts between they take the volts between 5 volts and 0, and they attach a number to it, and it could be from 0 to 200 and I think 25. No, 255. Now on this side, these are our digital pins. Where the analog is only input, these can be input or output depending on what we do. So they're labeled from 0 to 13. And some of them have a little squiggly line. So like 3, 5, 6, 9, 10, 11. These deal with doing pulse width modulation. And that makes it so we could vary the voltage. I'm not going to get into detail on that, but basically we can make a light dim or a motor speed up or speed down. Instead of just being on or off, with these pins we can make it so it slowly goes up and slowly goes down. Now these TX and then the RX, this is be like the transmitting and receiving. If we had some more complex interactions, we would be using these pins. But they could also be used as just any other pins. You don't need them just for communication. This button up here is going to be a reset button. That's also here. There's a reset pin. If we ever had something where we can't reach this button, it might be nice to connect up a reset button somewhere else. But this will restart the sketch. So if whatever sketch we have on here, the program, if whatever reason we want to restart it, we can push this button and it'll start over again. The breadboard is set up just like this, where we have these pins, these solderless connections, where we can come and place a wire straight into it without actually soldering or doing other thing, and now we have an electrical connection. But these ones, they're not all connected. They're only connected in the rows. So these 5 pins across are all connected. These 5 pins are connected. These 5 pins and these 5 pins and so on. they're only connected, and there's no connection between the board. This is a split, and so this line is not connected to this line, and these aren't connected to the one below it. They are only connected with these 5 in a row. So each set of 5 you can connect. So if you want to connect 2 wires, you'll just place them in the same row. They don't even have to be next to each other. They could be far apart, but as long as they're in the same row, they are then connected. These side ones, we use these for positive. Since a lot of things need positive and a lot of things need ground, we just make one big long connection. So this whole strip is all connected, and this long strip is all connected, but they're not connected over here. If we wanted to join these two, if you want to put power across the whole board, we would connect the positive to the positive here, and we connect the negative to the negative here. Now with this connection, we have power to both sides. And it allows us to tap in, and so if we came in from our positive volts, we can come in from anywhere. Now, when we do our sketch, we don't need, we may not need, gosh, just lost my train of thought. Anyways, there we go. Oh, we don't need to match the colors. It could just be whatever. But if it helps you to keep track and match the same colors that they have, go for it. So I've put in the 5 volts to the positive side here. 5 volts to be positive. Ground means negative. So now with this setup, I now have power through all these. Okay, so all this is positive, all this is negative. If I wanted to turn on a light using this, I could. So I want to make it so these not in the same row. Notice that I have 2 lengths on this. There's a long and a short. This is the positive side. This is where electricity needs to go in at from the voltage. This is where ground needs to be connected to. So I'm going to stack it into a different one, making sure both legs are going into a different row. And I need to connect. If I don't want to run full volts through this because it'll break the LED. It can't handle the 5 volts. But coming out of the negative side, I can take this resistor, which kind of reduces the electric flow. I can place it in here into the ground, and that allows me to protect that LED. Now coming from here, I have different options. So I have a positive here, so I can connect positive and then connect positive into this. Let me just power it up. Let's plug it in. So we have power in the Arduino now. I could come in here, and if I just connect that, I've just created a loop. And so the electricity comes out of the 5 volts onto the positive side, through the positive side of the LED, and we, somewhere in this resistor, it doesn't have to be the negative, but it also could be the positive, we need a resistor in there to slow it down. Now this one's labeled with the orange, brown, gold. That is to be 330 ohms. The other ones that are the brown, black, orange, gold, that would be like the 1,000, the 10K resistor. Anyways, but this is uncontrolled. It's just one big loop. If we wanted to control this, instead of pulling volts this way, what if we had the volts come from the Arduino itself? We can still leave this connected. The 5 volts don't matter anymore. But remember, we were telling you the pin 13 right here was connected to this LED. So if we plug it in here, your Arduino should have come in with this pre-loaded. So you don't even need this. You don't need the sketch or anything right now. All we're using is just the power. And that first sketch, this blink sketch, is already loaded. So you notice it's on for a second, off a second. One of our next videos, we're going to show you how to modify this. But basically, you need to go away from this knowing that you need volts to make one complete loop from positive into negative. These can be counted as positive, but we just need to be hooked back into a ground. Pin 13 is connected to this LED light, and it's already got this code on here and makes it blink. That'll do for now.